Okay, good afternoon, everybody. My name is González-Pinto. I'm the Chief Operations Officer from Saitec Offshore, and I'm going to speak a little bit about floating wind and our business. Oh, sorry. Oh. So this is that way, okay. So I'm not going to take much time to explain why we need clean, cheap energy. I think it's pretty obvious, and we have been speaking about that for the whole conference. So yes, I'm going to explain why we think floating offshore wind is going to be a big thing, and it's quite a big thing. It was going to be one of the biggest things in energy production for the future. The key point of floating offshore wind is that it removes the limitation of depth for offshore wind, and that makes that we could go to any coastal region in the world to install offshore wind. And that's pretty interesting because it gives us access to wind resource, to the best wind resource we can choose, and that makes sense because when you get to the calculation of levelized cost of energy, at the bottom, dividing everything is the energy production. So if we increase the energy production rate, we are able to reduce the cost of energy. Also, we can have unlimited power, as when we can get bigger offshore wind farms, which also will reduce the cost. And also, it's interesting when we get to wind turbines that are becoming 12, 15 megawatt wind turbines, which is getting a pretty risky asset, and giving bigger wind farms will de-risk the situation. Also, we have no reduced visual impacts and reduced environmental issues. We are just installing and installing the solution. We just have no NIMBism because where we are going to install the wind farms, there's not going to be anybody. And also we benefit from all the benefits from offshore wind. We generate good jobs, quality jobs for the local communities. And if I have to summarize why we think floating is going to be one very big thing in energy production, is because we are globalizing offshore wind. We're taking offshore wind from Northern Europe, this unique place in the North Sea, where you have shallow waters and very good wind resource, and we can take offshore wind to wherever we want, obviously close to the coast. We must consider that 71% of the surface of the Earth is the sea, and that countries like most Europe and Japan, 80% of the wind resource is located in waters deeper than 60 meters. So just I'm going to explain a little bit what we've created. We have created SAF, swinging around twin hull, which is a pressurized concrete catamaran shaped solution, and we've designed this concept in order to reduce the cost. All the analysis, all the conception of it has been to reduce the cost, reduce the capex, reduce the opex, and increase the production. So how we did this was we took not a naval engineering view, but we took a civil engineering view. As I'm going to say later on, we come from an engineering firm. We know pretty well the good things of concrete. So we decided to go for concrete. Concrete is cheap, and concrete is durable. And it can withstand the marine conditions for several, and as you can see, to any harbor, any port, concrete is still standing there. Another key point for us was we tried to onshoreize the concept. As we can see, we plan to precast all the parts, install the wind turbine onshore, and then take it to the water. We think this is the best way. We reduce risk, reduce cost, and we can control the production. Also, we want to do a plug-and-play solution. We want to just simplify the installation as possible and get something that is really, we get it in the port, we send it to the water, and we just plug and play, and then we start operating it. So we allow, one key point is that our solution is totally different approach, and we allow our platform to rotate along one point. So yes, I'm running out of time. So the big thing and the unique selling point is very clear. We are the most competitive solution for 35 meters depth onwards. I'm not saying we are the most competitive solution for floating, and say that we are the most competitive even compared to bottom fixed. And I think that pretty much says everything when you can get floating wherever you want at a reasonable cost. Okay, so running out of time. So as I said, I want to say, yes, Saitec is not a common startup. It's a spin-off from Saitec Engineering, where it's 350 people working all over the world. And we created the company last July, and we have all the IP rights on this solution. Another key point is that we don't want to be an EPCI or constructor or developer on this technology. We plan to be still an engineering firm, and we plan to have the revenues back, obviously with the engineering services, but also with a royalty arranged with the EPC contractors or developers that employ this technology. We want to also, we have the vision and strategic vision to always partnership with local partners. As we see in offshore wind, local is really important. So when we are working in Japan, we work with Japanese companies. And when we go to America, we want to with American companies. Sorry for the time. Just 1 second. So yes, the key point is that next summer we are going to install our first 2 megawatt wind turbine. We are also working in our first commercial project in Scotland with 2B Energy, which is a wind turbine manufacturer. And just, well, we are working on the markets, Japan and whatever. So just the key point, we are spending 11 million euros for our prototype. We have already raised 5.8, so we need the rest. But especially what we want to, I came here mostly to contact corporate ventures, which for us is the key point to establish a partnership and develop the market. Sorry for the time.
All right, thank you very much.